Hi all, myself Lakshmi from Department of CSE, St.Joseph's College of Engineering. Today we are going to see a small topic on the subject soft computing techniques. Okay, soft computing technique, it basically deals with how the system is artificially trained, like the inputs we provide to it and the training we give to the system so that it can work on itself and produce the corresponding output that the human with or without the human intervention. Okay, and today we are going to mainly focus on the first topic is competitive learning. So this topic comes under unsupervised learning. Before that, first we should know what is learning. Learning is the process of making the system learn by itself. Okay, it can be classified as supervised or unsupervised learning, and this particular topic it comes under unsupervised learning. Okay, now getting into what is competitive learning. Usually the learning process consists of an artificial neural network, which is nothing but the neurons are interconnected with each other similar to the human brain structure. Okay, learning can be classified as either supervised learning or unsupervised learning or reinforcement learning. These are the very basic three steps that we must know before getting into this particular topic. So we will first see what is what. First thing is supervised learning. As the name suggests, this type of learning is performed with the help of a supervisor or trainer, that is with the help of human intervention. The system trained by itself, but there will be a external character or external human to monitor or supervise the system. This is the first type. And the second type is unsupervised learning, where there is no human intervention, and this can be performed like even without the unlabeled set of data. We will get in deep about the labeled and unlabeled data while looking on the competitive learning methods. Okay. And the third type is reinforcement, which is the combination of both supervised and unsupervised learning. So these are the basic things that we must know before getting into before getting in depth about soft computing. Okay, and this topic competitive learning, the first point here is that it is under unsupervised learning, which means that here there is no intervention of human, only the machine is going to calculate all the input, process the input, and we are going to get the corresponding output. As I said earlier, this learning process is done in the form of artificial neural network, where the neurons are interconnected highly with each other. So here the basic process or the basic aim of competitive learning is that the neurons compete with each other to form different patterns of data. This is the normal process in any type of learning. And here in competitive learning, the main aim is that which neuron should form together so that the neuron becomes more stable and more powerful. That is the main concept of competitive learning. So here, as I just said, the first point is unsupervised learning, and the second one is the way in which the neurons compete with each other to form different kinds of patterns of data. And the main concept here involved here is best matching unit, which is BMU or winner neuron. So best matching unit, as the name says, the main aim is to find the best neuron or the best nearest neuron that matches the requirement of the user. So this is the concept of competitive learning. Okay. Next step is, I have already said in the introduction that unsupervised learning works even with unlabeled data. So here we will see what is unlabeled data first. Unlabeled data is the one, or unlabeled data is used in the unsupervised learning, where there is no clear picture of the data being used, like the user will not be knowing the proper inputs and the proper outputs. Both the input and output will not be clear, or it may be like partial or vague. With the improper data or incomplete data, we are going to process the given data using competitive learning. Okay. Next one is the way in which the competitive learning works. Here the similar inputs are made or clustered together. Okay. The similar inputs in the sense, all the process in the neural network will be computing based on the weights associated with it. These weights are nothing but the nodal weights associated with the network. For example, consider I have two inputs x1 and x2. So these are my two different nodes, and these are the inputs being given to the neural network. The way in which it attached to the next neuron or the next node is the weight associated with it. Consider this is the input x1 and x2, and I have the weights here W associated with it, so that it produces the output y. This is the basic structure of a neural network, and here the best matching unit is going to be selected with the help of competitive learning algorithm. This is the basic thing about what is supervised learning, what is competitive learning, and now we are going to get in detail about how it actually works. So before getting into how it actually works, we must first know the three different key ideas of competitive learning. The first and foremost main concept used here is winner takes all. Okay, now we are going to see the key ideas of competitive learning. The first one is the major concept used in competitive learning, which is winner takes all. As the name suggests, the winner neuron. To find the winner neuron, we have a list of steps that is to be followed, which we will be seeing it later. Here it is about the winner neuron. Once the winner neuron is identified, it becomes the major neuron based on which the weights are adjusted. Initially, the weights of winner neuron is adjusted, and if required, the adjacent neurons weights are also adjusted, so that the competitive networks becomes more stable, and the transmission between neurons become more eligible and faster. Okay, this is the basic key concept here, and as I earlier said, unsupervised learning method is followed here, so that the unlabeled data set is being provided to the entire learning network. This is the basic key idea. Now we will get in deep into the algorithm or the methodology used in competitive learning. Okay, the first step, that is identifying the input. Here the input is usually presented in the form of vector, mostly of 2D vector. Okay, the input representation should be in the form of 2D vector. That is the initialization step, followed by calculating the similarity. So here the similarity represents the distance between two different neurons. That is, the distance here is the time required or the weight associated between the neurons, so that it is attached and transmitted between the neuron 1 and 2. So here the distance between the neurons is calculated in the second step, and the formula we use here to calculate the distance is Euclidean distance method. We use the formula, where the formula goes as such: square root of x1 minus x to the whole square plus y1 minus y to the whole square, where the x1 and y1 are the input vector and the weights of the corresponding neurons. So this is the formula to calculate the distance between the neurons. So once the distance between the neuron is calculated, the next step here is to identify the winning neuron. Okay, here the winning neuron concept is to be made very clear. Why? Because once you select the wrong neuron as the winning neuron, the entire concept becomes a mess. So to select the winning neuron, the basic idea is to find the best matching unit. So the best matching unit is calculated based on the smallest distance between the neurons. So once we find the distance based on Euclidean distance, we will get to know the different distances. Like when there are, for example, 3 neurons, we will be getting 3 different Euclidean distance as a result, right? So among the 3, you have to find the smallest one. The smallest the smallest distance neuron will be considered as the best matching unit or the winner neuron. So once the winner neuron is identified, it becomes easy. The next process becomes further easier. Next thing is, we are going to update the weights of winner neuron. So again, how we are going to update the weight of winner neuron is, we are going to use the formula here. Okay, I am writing the formula here. To find the new weight, the formula used here is old weight plus eta into the input vector minus the old weight. So this is one of the main formula used in unsupervised learning methods to calculate the weights of the newer updated weights of the neurons. Okay, the new weight represents the weight that is to be updated. The old weight represents the initial weight of the neuron. For example, consider you are starting the network with the weight of 0.1, that will be your old weight, plus, and this symbol represents eta. Eta here is the constant value, so which ranges between 0.1 and 0.5. So this depends upon the user or the machine. The eta value can be any value between 0.1 and 0.5. Normally it is taken either as 0.1 or 0.3. Okay, these two are the mostly used eta values. And the input vector is the input vector is the previous vector or the vector that is actually assigned to the network. Okay, the input that we give to the neural network at the initial stages, and then old weight, the same old weight is used here. So once you calculate the new weight, you will get two different, again you will get x and y of the updated weights of x and y. So with this x and y, you can either stop the competitive learning process, or in addition to it, if needed, you can update the weights of the neighboring neurons also. But the this particular fifth step is optional, and it is mostly skipped in competitive learning methods. Why? Because here the main concept is with only the best matching unit. So once this unit is found out and the weight is updated, with there itself you can stop the program. And the fifth one is highly optional, and in most of the cases this is not being used. Okay, so this is the basic algorithm of competitive learning. The next one is the places in which this kind of learning process is used. First one is self-organization maps, or the next one is Kohenone maps. Okay, both the things are mainly used to reduce the higher dimensional space into the lower dimensional space. The usage here is reducing consider you have a higher dimension space. So whatever the dimension may be, when this particular algorithms are applied over this, mostly you get it into a two-dimensional space at the minimum. Okay, this is the major use of these two different types of networking, and competitive learning is mainly used in these different types of networking process. Okay, now we will see an example based on competitive learning process. First one, consider I have the input as the first step says the input should be vector. So consider I have been given the input vector as 0.5 and 0.6. Okay, now I am going to have three different neurons. Consider I have a network with three different neurons, and each neuron has the weights associated with. Consider these three as the inputs, right? The neuron have 0.1 and 3, the x and y values. Similarly, the neuron 2's value and the third neuron's value is being given as the input. This is the problem statement that we have got. Now we are going to apply the competitive learning algorithm to this particular problem. Going step by step, the first step is initializing the vector. So here the input vector is 0.5 and 0.6, followed by the neuron weight is already here. The same step has to be repeated over here. And the second step is calculating the Euclidean distance. Okay, now the formula, we should calculate the Euclidean distance for three different neurons. Why? Because we have three neurons in our artificial neural network. So I am calculating for neuron 1, I am first calculating the Euclidean distance. So ED represents the Euclidean distance, and the formula here is x1 minus x to the whole square plus y1 minus y to the whole square. So consider this is the input vector. Okay, so let this be the x value. Okay, and this is the y value associated with this. So the first neuron 0.1 and 0.3, and the input vector here is input vector. It does not differ for all the three neurons, it remains the same. The initial vector is being used 0.5 and 0.6. So by the formula we get 0.1 minus 0.5 the whole square plus 0.3 minus 0.6 the whole square. Okay, the step 2 goes as such. We are going to calculate the Euclidean distance, that is the similarity between the distance, that is what we are going to calculate here. So for the first neuron we have to calculate for three different neurons. So I am starting with the first neuron, which has the input weights as 0.1 and 0.3. Okay, so the formula is root of x1 minus x to the whole square plus y1 minus y to the whole square, which we saw earlier. So here the x value will be the input vector's value. So the x1 is the 0.5, which is the input vector that we have considered in the initial inputs. So 0.5 minus, and y1 will be the weight of the neuron, which is 0.1. So here it goes as 0.5 minus 0.1 the whole square, plus again the x2 will be the second input vector, which is 0.6 minus y2 is 0.3 the neuron weight of the first neuron, which is 0.3 the whole square. So doing the mathematical calculations, we get square root of 0.25, and the weight here is the distance here is square root of 0.25, which is 0.5. In a similar way, we are going to calculate the distance for neuron 2 and neuron 3, where the neuron 2 is 0.6 and 0.7, and the input vector remains the same as 0.5 and 0.6. So we are calculating the same thing, x1 minus x2 the whole square plus y1 minus y2 the whole square, which is 0.5, that is the input vector, minus the neuron 2's weight associated with this 0.6. So 0.5 minus 0.6 the whole square plus 0.6 minus 0.7 the whole square, which is 0.141. The next step is calculating the distance for the third neuron. Same mathematical calculations are performed, and the distance we get here is 0.566. Okay. In this step, we have calculated the distance between the neurons, like with the different input weights for neuron 1, 2 and 3. The third step is to find the winning neuron or the best matching neuron. As I already said, the best matching neuron is identified based on the distance associated with this. The distance in the sense, the neuron with the smallest distance will be considered as the best matching unit. So what we have here is the first neuron's weight is 0.5, the second one is 0.141, and the third one is 0.566. So among these three, the one with the smallest distance is the second neuron, which is 0.141. So from the algorithm, the second neuron will be considered as the best matching unit. That is what I have written here. Based on the distance associated, neuron 2 will be considered as the best matching unit or the winner neuron. So it is similar to how a competition winner is announced, right? For whichever neuron the distance is very less, that will be the winner neuron. So step 2 is done here. So once we have find the best matching unit, the next step is obviously to update the weights associated with it. We go by the formula W nu, which is weight nu equal to the weight old plus eta. I already said this is the constant, which can be between 0.1 and 0.5, okay, and x is the input vector used here, and W old is the old weight or the initial vector weight. So again, to update the weights, we have two different inputs in the second neuron, which is 0.6 and 0.7. So we have to update the weight of first neuron, and then we have to go to the second input of the neuron. The first weight here is 0.6. Applying the formula, then this is the new weight, okay. Do not confuse between the new weight and old weight, okay. To calculate the new weight, I am going by the formula. The old weight here is 0.6 plus, I am using the constant factor here as 0.3. As I said earlier, the eta values mostly used here is 0.1 or 0.3. So I have taken the value of 0.3, which is user defined, it can be anything. So 0.3 into, from the formula, x minus old weight. So x is the input vector. The input vector is 0.5 minus the old weight is 0.6. So this is how the mathematical calculation is done here. From this I get the updated weight 1 of the neuron 2 as 0.57. Now I am going to update the weight of the second vector in the same neuron. So applying the same formula, that is for the second neuron, and the second input we get 0.7 plus 0.3 into 0.6 minus 0.7, which is 0.61. This is the weight of the second input in the neuron 2. Now, and the final step is I am going to update the weight of the best matching unit. From this, the updated weights are neuron 2 or 0.57 and 0.67, which was initially 0.6 and 0.7. Okay, this is the final step of the competitive algorithm, and going on further iterations, like once the convergence is not reached here, you can still keep on looping the iteration so that the expected convergence is arrived. Okay, so after this complete iteration, I have changed only the weight of neuron 2, and the neuron 1 and 3's weight remains unchanged. Okay, so this is about the competitive learning algorithm.